Welcome and thank you for joining. In this video, we'll go over the step-by-step process to finding the equation of a trigonometric function when given its graph. As you can see here, we have the curve of what we can call a sinusoid or maybe a cosinusoid. We know that they are the same curves. The only difference between them is a phase shift of 90 degrees. And we are going to try to find the equation of it as a sine function. So we'll start off by writing the equation of the basic sine function y equals sine of x. And to determine the equation of this particular curve, we're going to need to determine the amplitude, the coefficient k, which indicates the number of cycles in a period, the phase shift p, and the vertical translation c. We're going to start off by locating the maximum and the minimum of the graph of this function. So the maximum of the function is at 5.5 and the minimum is at 2.5. Now, based on the max and min, it would be easier for us to determine the equation of axis of symmetry. Axis of symmetry will go through the graph halfway, so right in the middle between max and min, and that's why it's important to locate max and min first. So we're going to draw the axis of symmetry and determine where it's passing through at what y value, and write its equation y equals 4. Now the equation of the axis of symmetry will help us also determine the last coefficient, the coefficient c, which in our case seems to be equal to 4. Next, we will be able to locate a sine cycle. Remember that a sine will start and end with an intercept with the axis of symmetry. So we're going to start here and end in here. And then we're going to highlight the one cycle. Normally, I like to highlight the cycle that is closest to the y-axis. And in the meantime, I prefer to write to highlight or select the cycle that is at a horizontal translation to the right, but there is nothing wrong with selecting either one, left or right of the y-axis. So next, we are going to focus on finding the coefficient a. So we like to deal with the vertical coefficients first, a and c, just to follow a certain order and that we remember. So when we follow a routine in solving a problem, we become faster at solving it. And that's the only reason why I encourage everyone to establish his own or her own way of solving a specific problem from a specific group. Okay, so now let's take a look at how we determine the coefficient a. The coefficient a indicates the amplitude of a function. The amplitude of the function is halfway or half of the height of the function, so half of the difference between max and min. Another way of describing coefficient a is the distance of the max from axis of symmetry or the distance of the minimum from the axis of symmetry. So in our case, then we're going to say that the value of coefficient a seems to be equal to, from here to here, 1.5 units. So we're going to write 1.5 for coefficient a. So in the next step, we're going to, once we locate the sine cycle, we are going to determine where the start of our cycle is. The start or the beginning of the cycle will help us determine the phase shift P. And from the start of the cycle that we highlighted, we're going to drop a perpendicular on the x-axis so that we can see the point where the graph has started, so the x-coordinate at the starting point. And as you can see here, we have the graph started at 30 degrees. That means that the phase shift P will be 30 degrees. So next, we will have to determine where the end point of the graph is. Now, the reason why we need to know the start and the end is because we need to determine the period length, so how wide one cycle of the graph is, or the period length of the function. The period length of the function is simply calculated by subtracting end minus start. So from end, subtract the starting point of the graph. And in our case, it seems that the period length starts at 30, ends at 210, so it's about 180 degrees. That will help us determine the coefficient k, which is the coefficient of x. And coefficient k is measured as the basic period, which for sine and cosine function is 360 degrees divided by the period length, which in our case is 180 degrees. So that will give us a period length again of 180, and 360 divided by 180 would be equal to 2, which means that the coefficient k equals 2. And voila, we have the equation of the sine function. I encourage you to continue with the next equation, or the next graph, I should say. And this is a graph of we want to interpret it as a graph of a cosine function. Follow the exact same steps, and you'll be able to determine the equation of it. I hope you found the instructions useful. Bye for now, and thank you for learning with me.